This meeting is being recorded.
For problem 9 from chapter 5, we are asked to look at each of these compounds and locate the chiral centers and then identify the configuration. So first we'll locate and then we'll identify as either R or S using the Kahn-Ingold prelog prioritization technique. So let's take a look at this first compound here. So we're given ephedrine and we see that there are two chiral centers designated by these wedges here. And let's take a look at the one on the left here. So we'll look at this one and we notice that we have a oxygen here. So this would definitely be our highest priority group. Then we go to the right or the left and we see a carbon. But we would say that as far as prioritization, this would be our second highest here, because this carbon is also bonded to a nitrogen, whereas we would call this number 3 because this carbon here is bonded to only carbons, right? All carbons versus a nitrogen, a carbon, and a hydrogen. So by atomic weight, we know oxygen is the heaviest, so that's why that prioritizes number 1. And then when we have to choose between our two carbons, the nitrogen is heavier than the carbon. So when we look at our numbering here, we know that our lowest priority, if we were to draw it in, would be on a dash. So that would be our hydrogen. That's also not drawn in, but inferred in this picture. So we would then look at this site and determine it to be an R configuration if we went around 1, 2, 3. Right, so I'll remove that arrow so it's easier to see when we do our next center, but this will be R. And let's take a look at this configuration here. So we know that we have a methyl group, right? This is our carbon that we're considering. So we have a carbon here with 3 hydrogens on it. Then we have our nitrogen group over here. This would definitely be priority number 1. And then we have a carbon over here that's bonded to an oxygen, a hydrogen, and a carbon. So OHC over here versus HHH. So we know that this would be my number 2 priority, and then down here would be number 3. And let's take a look at this. Our hydrogen is also on a dash. So that's our lowest priority group. So we would look at this configuration. We would say that it would be S by the way that it's moving counterclockwise. And we would say that the carbon on the left that's chiral would be R configuration. The one on the right will be S. All right, so we'll do the same here with this second compound with holomen. And we also see 1, 2 chiral centers here. So I'll start with the one on the right here. So that bromine is the heaviest, so that would be our first priority. We also have a hydrogen here, but this time this hydrogen's on a wedge. So whatever determination we make for this, we know that it's going to be the opposite. So we will invert our configuration at the end. So that's our group 4. This is going to be our group 2 over here. We know that because the carbon that we're bonded to has a chlorine attached to it. And then over here, we just have hydrogens. So this would be my priority 3. If I looked at this, I would say, well, it looks it looks S because we are going counterclockwise. But again, we need to invert to an S configuration because we have to switch our lowest priority group to be on a dash instead of a wedge. So we would call this an S configuration on this carbon here. Or rather, I'm sorry, we would go from S to R, right? So this would be our R configuration on the carbon on the right. So let's take a look at the other site. So we have a carbon here, I would like to point out, that's attached to that bromine. So our highest priority group is this chlorine, which is on a wedge. And then we have, we have a carbon here, and a carbon here to compare. So up here, the one with the bromine, this will be my priority 2. This carbon over here will be my priority 3 because that's attached to a chlorine. And then this would be my lowest priority group over here. So my lowest priority group is not on a dash. So again, we would take a look at this site here. We would think that it would be R because it's going to counterclockwise in direction, but we know we need to invert it because my lowest group down here needs to be on a dash. So for the second compound, this holomen, we have going from left to right. Our first chiral center would be an S configuration, and the second would be R. So let's take a look at compound C. And let's see, so compound C here, we have 2 chiral centers again, right? The 2, we have our thing, our methyl group on a wedge, and then we have our hydroxyl group on a dash here. So we'll start on the right here. So I know that my my hydroxyl functional group, that oxygen, that would be my highest priority. I also have so that's on a dash. So on my wedge, I'm going to have a hydrogen. That's my lowest. So we know we're going to have to determine the configuration, then invert it. Now let's look at these 2 carbons. So we go here and here first. This carbon on the right is bonded to 2 carbons and a hydrogen. This carbon on the left here, we have that is bonded to an oxygen, right? So we have a higher priority on this side here, actually OO and C, it would be bonded to. Right, so this would be my priority 2. This would be priority 3. So again, I know I need to change my configuration. So it looks like we would have an S configuration going in a counterclockwise. But when I invert this, I'm going to end up with an R on this carbon here, this chiral center. And then let's move to the other site. So again, we know that this would be my highest priority here because the carbon on the methyl group, that has only hydrogens, right? So hydrogen, hydrogen, hydrogen. And then over here, we see we have carbon, carbon, hydrogen on this carbon here. So this is my priority 2. This will be number 3. This time, my lowest priority again would be my hydrogen. So that's on a dash already. So once I determine my configuration, it's going in the counterclockwise direction, I would retain it as an S. So for my last compound going from left to right, the 2 chiral centers are S and R.